All right, I wanted to put up a screencast on application exercise 4.6. And here we've got this Chinese manufacturer of RPG launchers. They can sell both to ISIS and Syria. And we've got ISIS, their demand is quantity demanded equals 1,000 minus P. And then we've got Syria demanding, according to the relationship, quantity demanded is equal to 2,000 minus 0.5 P. And then we've got a constant marginal cost of producing an RPG launcher of 200. So the question asks us, compared it with a single price monopoly outcome, producer surplus for a perfect price discriminator in the two markets is greater by what? And then compare it again with a single price monopoly. If they can segment the markets, what's the increase in producer surplus? So I'm going to walk you through it the way I started it. There was that other way I did it in class. Either way works. But let me show you what I did. Before we leave this page, I don't have room to write here. But what I did is I noticed that quantity demanded for ISIS, 1,000 minus P. Quantity demanded for Syria, 2,000 minus 0.5 P. Remember to get, if I just treat them as a combined market, I just sum the quantity demanded in ISIS plus the quantity demanded by Syria. And so anyway, so when you add those two demands together, summing across quantity, you get the combined market demand is equal to 3,000 minus 1.5 P. And the inverse, I'm just going to proceed as though there's one combined market that's going to make sense to sell to. The inverse demand for that combined market, remember we have P as the dependent variable. I'm just going to multiply through by 2/3. So that's P is equal to 2,000 minus 2Q over 3. And remember, marginal revenue function for the combined market is the same y-intercept, has the same y-intercept, but is twice as steep. So that's going to be 4/3 Q, 4Q over 4/3 Q, 4/3 Q, which is 4Q over 3. All right. Remember marginal cost. I've got to start compressing here. Marginal cost equals marginal revenue is my output rule. And so 200 equals 2,000 minus 4Q over 3. And when I solve, I notice I've got Q and nothing else, so I can solve for Q. That's equal to 3/4 times 1,800, which is equal to 1,350. And that's, I can plug, that's the quantity when I did it this way. I can plug that into the combined demand curve, or the inverse demand curve. I can plug it for the Q right here, and I can solve for P equals 2,000 minus 900, which is equal to 1,100. But here's where I said, whoa, wait a second, that's ridiculous. A combined market, if I'm selling in both markets, I wouldn't price at 1,100. And the reason I knew that was the following. I'm going to back up a slide. Notice that, where is ISIS? Okay, ISIS is here. ISIS is inverse demand curve. I'll write that down. Their inverse demand curve is P equals 1,000 minus Q. Well, that's got a y-intercept, a price axis intercept of 5,000. So if at a price of 1,100, there would be no sales to ISIS. So that doesn't make any sense. So that's how I knew, whoa, that doesn't make any sense. I'm only selling in Syria, and then I solved for the Syrian market only monopolist outcome. There's another way to do it. I guess that's worth showing you. The other way to do that is to realize that Syria's inverse demand curve is 4,000 minus 2Q, and ISIS's demand curve was 1,000 minus Q. If I map the combined demand curve, I'm going to get something like this. You can see it when you go to graph the problem. You see it. It jumps right out at you. So we know that at prices from 4,000 down to 1,000, only Syria's in the game. And then at prices of 1,000, then ISIS is in the game. And then I need these, to finish this graph, I need to know what the quantity demanded there is. And if price is 1,000, that's a quantity of 1,500. I'm just plugging that into Syria's demand curve, 4,000 minus 2. P equals 4,000 minus 2Q. So 2Q, P is 1,000. 2Q is equal to 3,000. That means Q is equal to 1,500. And then finally I get the quantity intercept from the combined market, and of course I did that already. That would be 3,000, and I didn't draw to scale, which would have been nice to draw to scale. Well, let's just erase that a little bit and get that, draw that to scale a little bit better than I did. So this is 1,500. My x-axis intercept would be about there. Once I do that, I know that the marginal revenue function, the combined marginal revenue function, looks like this. I'm just going to have a little ghost. That's 2,000 there. And the combined marginal revenue function, if I'm only selling to Syria, twice as steep, has a intercept of at 1,000, and then it keeps going down, right? That's the marginal revenue of Syria alone. But then as price drops to 1,000, I've got the marginal revenue of that combined market. So I'm looking for a line that's twice as steep as the combined market is. Well, that turns out that's going to intersect the, since this is at 3,000, we'd have this combined market demand and combined market marginal revenue function that would cut the axis right there, marginal revenue. Well, I know my marginal cost is at 200. That's supposed to be a horizontal line. And so my marginal revenue, even for this combined market, is everywhere below marginal cost. So I wouldn't sell to ISIS. I knew it that way. So I'm looking for this point here, where I'm just selling to Syria. So the graphical solution can get you there too. I guess I have room right on this space. I solve for the Syrian only market. The inverse demand curve turns out to be P equals 4,000 minus 2Q. Marginal revenue then is 4,000 minus 4Q. I set that equal to my marginal cost of 200. Oh, I'm sorry. I'm trying to go fast because I see the time on the screencast is almost at 10 minutes, and I know I run out of time at 15 minutes. I can't get it up on YouTube anymore. So anyway, Q is equal to 3,800. Sorry, 3,800 divided by 4, which is equal to 950. Plug that back into the inverse demand curve. Price is equal to 2,100, and producer surplus is 2,100. That's the price minus the constant marginal cost. And then I multiply through by quantity. I get 950, and that's 1,805,000. That's the producer surplus in our base case. So I calculated out the perfect price discrimination case sort of offline, so I didn't burn my time. The way you do that, you draw the demand curve for ISIS, you do the same for Syria, and you realize the perfect price discriminator is going to sell everyone that is valued more than the marginal cost, and it can get the reservation price so from each buyer. So for ISIS, this area below the demand curve and above the marginal cost is going to be producer surplus, and I did that, 320,000. For Syria, it's the same deal. They can get the reservation price for every rocket launcher under this scenario, so it's the area under this demand curve and above the $200 marginal cost. And when you multiply that through, you get producer surplus from Syrian sales, 3,610,000. And then you add those together, you get, if I've done my math correctly, 3,930,000. You take that, the difference between that and the 1,805,000 you get from the single price monopoly case, and you get that first degree price discrimination increases producer surplus by 2,125,000. Now we just have to do that segmenting case. To solve the segmenting case, you simply just take the ISIS market by itself, marginal revenue, marginal cost. You find that the monopolist sells 400 to ISIS and prices each rocket-propelled grenade launcher at 600. Remember, we did that before for Syria, and we got 950 produced and sold at 2,100, and the producer surplus from that case, again, is 1,805,000. You notice that producer surplus in this case has gone up just because you're selling to ISIS now, and their market separate goes up to 160, goes up by 160,000.